Welcome to my channel. Today we will discuss Leetcode 128, which is longest consecutive sequence. So let's read the question. It is given that given an unsorted array of integer nums, return the length of the longest consecutive element sequence. You must cite the algorithm that runs in O of n time. So you will be given an integer nums, means a vector, uh, an array that will have some elements, and you have to return the longest consecutive element. Means let's see the example, discuss one. So the array given is 100, 4, 200, 132. So you have to uh, sorry, in this longest sequences 1, 2, 3, 4. So it picked this one, this two, and this three, and this four. So means you have to randomly pick the element from this given array, and you have to tell what longest consecutive sequence you can create. So it is not like that. If you pick this, you need to pick the next one. Not like that. You can pick any one, and you have to tell what longest subsequence you can form. So let's discuss the approach. So one of the brute force approach that could be you can simply sort this array. So after sorting, it will become 1, 2, 3, 4, 100, and 200. So if the array is sorted, you can simply traverse the array and find the longest consecutive sequence. So the time complexity for this will be n log n. That will take n log n. That will take for sorting. So, but the question is saying that you must write an algorithm that run in O of n times. So let's optimize this approach, or think some optimized approach. So another approach that is optimized is you can take a set. You can take a set, and in that set, add all the elements. So inside in the set, you add all the elements. So inside you will have 100, 100, 4, 200, 1, 3, and 2. And after adding the elements in set, simply uh, traverse this array and check whether this element plus one, this element plus one present in this set or not. I will tell why I'm searching for 100 plus 1. Why not 100? So I'm searching for 100 plus 1 because suppose if I'm having a sequence 1, 2, 3, 4 in this 1, 2, 3, 4. So if I am at 4 and I will check for 4 plus 1 is present or not. So if it is not present, then this 4 is the last element of my sequence that I'm looking for. Okay. Or if it is 100 and if I'm looking for 100 plus 1, which is 100 on 1, that is not present in the set. So I mean, this is the last element of the sequence that it can form, which is 100 only. So, or suppose if I am at 2 and I will look for whether 2 plus 1, 3. 3 is present in this set or not. So 3 is present. This means I'm not at the end of the sequence that I'm looking for. There is some element that is greater than this 2 and is part of the sequence, uh, which is present in the set. So if I'm able to find 3, then this 2 is not the last element of this sequence that we are looking. Why we are looking for the last element of the sequence? We are looking for the last element of the sequence to avoid repeated searching. Suppose if we search for 2, okay, search for 2, and we start finding all the means consecutive elements. So I will search for, I am at 2, and then I will search for whether it is one is present or not. Okay, so let's discuss this part after this explanation, so you will be able to understand clearly. Let me clear the screen. So I will check for 101 is present in my set or not. So it is not present. Then this 100 is the last element of my sequence that I am looking for. So what I will do inside, I will run a while loop. I will run a while loop and uh, will will search for consecutive elements. So if 100 is the last element, then I will search for 99. So I will do 100 minus 1 and will check whether 99 is present in my set or not. So it is not present. So it is not present, then I will keep a count variable. Okay. I will keep a count variable and initialize it with 0. Okay. And inside that while loop, I will add a condition till I am able to find, and also I will take a num that I will initialize with this element 100. Okay, and I will run loop till I am able to find this num. So first I will search for this 100. So I'm able to find this 100. So I will increase my count inside this loop. Count will become 1. Okay, and will decrease my num by 1. So num I will do a minus 1. So it will become 99. Now in the next iteration, it will search whether 99 is present in my set or not. So 99 is not present. So the count that I got is 1. Means from 100, I can form a consecutive sequence of only one element, that is 100. Also, I will keep a rest variable resultant that I will keep on maximizing. So currently, initially I will initialize it with 0. And so I will maximize this rest with the count. So count I get 1. So I will update my resultant with 1. Now I will move to the next element in the loop. So let's clean my screen. So next element is 4. So next element is 4. So I will check whether 4 plus 1, 5. 4 plus 1, 5 is present in my set or not. So it is not present. So I will go inside the loop. The count variable will be initialized to 0. And inside the loop, I will check whether 4 is present in my set. Yeah, it's present. So I will do a plus 1 to my count. And I will decrease my num initially, which will be 4. 4. So inside the count will increase and num will decrease. Now num will be 3. Now I will check whether 3 is present in our in my set. So yeah, it's present. So I will do a plus in my count and decrease my num by 1. Again, I will check whether 2 is present in my set. Yeah, it's present. So I will decrease it with 1 and do a plus 1 in my count. And again, in the next iteration, I will check whether 1 is present in my set. Yeah, it's present. So I will decrease it by 1. It will become 0 and increase my count by 1. Now in next iteration, it will check whether 0 is present in my set. It is not present. So it will stop. And count we got till here is 4. So in my resultant, I will maximize with this count. So it will become 4. And after that, I will move to next index. So let me clean it. So this is 4 and my pointer is at 200. Now I will check for whether 201 is present in my set. So it is not present. So it will go inside the loop and will count the sequence of 200. So there is so it will count 1 for 200, and after that num will decrease, so it will become 199, and it will check whether it is present in the set or not. So it is not present. So for this count will be 1 only. So we are already having a result maximum, so it will not change. So my index will move to next element. Now I will wait, let me clean. So I will check whether 2 is present in my set or not. So it is present. If it is present, then uh, we will not do anything. We will continue. So it will go to next, which is 3. So I will check whether 4 is present in my set. Yeah, 4 is present. So again, we will move to next index. We will do nothing. We are having 2. So we will search whether 2 plus 1, 3 is present in my set. Yeah, it's present. Then we will do nothing. So our loop completes, and 4 is our result. So why we are moving with the tail only? Means if I have sequence 1, 2, 3, 4, so why I am starting with tail only? So, and in these conditions, I simply continue. I look for 1 plus 1, 2. If it is present, then I continue. This is because we want to we don't want to do repetition, because if I am if I am at 4 and I have done the calculation for the sequence which 1, 2, 3, and 4 are the parts of that sequence. So we have calculated when we were at the 4, we have done the calculation, found that we have a sequence 1, 2, 3, 4, which has the length 4. And when we are at 1, and if we again mm, if we start with the 1 and look for its sequence, so what we will do? We will do 1 minus 1. We will get 0. We will have count equal to 1, because 1 is the only element uh, with which is means if we consider 1 as the last element of a sequence, then we will have 1 only as the element. So we are doing repetition, because for when we are at the 4, we already considered this 1. So to avoid this, we are starting with the tail. Okay, so suppose if we are at 3 and we start with 3, so what we will get? We will get sequence like 3, 2, 1, and we will get length 3. So which is smaller? Because which is smaller? And previously we got a sequence which 3 is part of it, and it is greater. And so to avoid this recalculation, we are starting with the last element of our sequence that we are looking for. So time complexity for this will be O of n. Uh, yeah. So time complexity will be O of n, because uh, we are we are running a loop to iterate this array, and running a loop means it is not exactly n, but it is similar to n, because we are looking for sequence from the last element. So it will not do calculation for each element to find the sequence. That's why time complexity for this will be O of n. Now let's see the code. So in the beginning, I have added if condition ki if nums is having 0 or 1 element, then simply return the size of nums. And after that, I have declared a set and added all the element into the set, and I have taken a resultant variable and running a loop over the array. And I'm checking key whether I am able to find this nums of I plus 1 into my set. If it is not able to find st.end means it is not able to find, then only it will come inside and will take a count and num as nums of I, and will run a loop and will search whether num is present in the set or not. If it is present, then we will increase the count and decrease the num by one. And when this loop will end, I will maximize my result with the count. And this rest will be our result. So let's run this code. Yeah, so it passed given test cases. Let's submit it. Okay, it gave TLE. Why it is giving TLE? Let me check. It is nums of I plus 1. Okay. Okay, so this approach is, I think, giving TLE. So we need to optimize this approach. So to optimize this approach, what we can do, uh, for traversal, we are traversing over this array. So suppose if this array has a repeating element, so it will take time. So instead of iterating over this array, we can iterate over the set that we have created, because the set will have unique elements. And we will do the same, just we will, instead of iterating over the array, we will iterate over the set, because set has all the unique elements. So let's do the change in code accordingly. We will remove this and we will do info and next, and we set so we will do this one, and we will remove this one, this none, and question minus one. Okay, yeah, let's run this code. Let's fill in that semicolon used. And then let's try submitting this code. Okay, so it passed all the test cases. So the change was only this. Instead of iterating over the array, we can iterate over the set, because set has all the unique elements, which will save time. Okay, so that's it. Thank you for watching. Do like, share, and subscribe.